I hope you're having a wonderful Friday. I can't wait to see you all on Tuesday, and I hope you enjoy your 3-day weekend. So I'm a little bit sniffly today because my allergies are kicking my butt. So if I start to sniffle or sneeze, that's why. So I'm going to apologize in advance. But let's go ahead and move on to our lesson. So our lesson today is 2 equations for each relationship. Don't forget to write your homework in your planner. It's 2.4 and 2.5. Both of these are incredibly short, so if you use your time wisely today, you'll be able to get both of these done. And don't forget to write your learning targets in your notebook. Those learning targets are, I can find 2 constants of proportionality for a proportional relationship, and I can write 2 equations to represent a proportional relationship. Once you have your planner and notebook filled out, let's go ahead and move on to the warm-up. So our warm-up is missing figures. We're given 4 figures with figure 1 and figure 3 missing. Our first question is, what do you think the first and third figures in the pattern will look like? And our second is, describe the 10th figure in the pattern. Go ahead and pause here, attempt this warm-up, and come back once you're ready. All right, so to be able to answer these 2 questions, we must first analyze the patterns. If you notice, from figure 2 to figure 4, figure 4 is just 2 figure 2s put together. This means we can assume that from figure 1 to figure 2, figure 1 is going to be half of figure 2. So our first figure is going to include 2 blue tiles and 3 orange tiles. And now for our third figure, we can assume that our third figure is going to be figure 2 plus figure 1, and that would create the red figure that I am outlining in figure 4. It's going to include 6 blue tiles and 9 orange tiles. So, if we look at the ratio of blue tiles to orange tiles in each of these figures, we can notice that from figure 1 to figure 2, the ratio is multiplied by 2. From figure 1 to figure 3, our ratio was multiplied by 3. And from figure 1 to figure 4, our ratio was multiplied by 4. So we can assume that in the 10th figure, they're going to take our ratio of 2 to 3 and multiply it by 10, giving us 20 blue tiles and 30 orange. Once you have this done, let's go ahead and move on to our first task of the day. So, on Tuesday, we looked at the relationship from centimeters to millimeters. Today, we're going to look at the relationship from meters to centimeters. So there are 100 centimeters in every meter, and they ask you to complete the table, find the constant of proportionality, which is the number that you take our first column by, multiply it, and the number you multiply it to get the second column. So what did you take your length in millimeters by, multiply it by to get your length in centimeters? And then question 3 asks us to write an equation for this relationship. X is going to represent our length in meters, and Y is going to represent our length in centimeters. Go ahead, pause here, attempt these problems, and then unpause and come back once you're ready. Okay, so from our length in meters to our length in centimeters, we know that 1 times 100 is going to give us 100. So we're going to take all our lengths in meters and multiply them by 100 to get our lengths in centimeters. So 0.94 times 100 is 94. 1.67 times 100 is 167. And 57.24 times 100 is going to be 5,724. If we take any length in meters, it could be any number or any unknown number, which is why we're using the variable x to represent it. If we take that and multiply it by 100, that will give us our length in centimeters. So our length in centimeters is 100 times x. The constant of proportionality is 100 because we took all of our lengths in meters, multiplied it by 100, and got our length in centimeters. An equation for this relationship is going to be that y, our length in centimeters, is equal to 100 times x, which represents our length in meters. Once you have this, let's go ahead and move on to the next part of our problem. So now we're looking from centimeters to meters. We know that there are still 100 centimeters in every meter. So go ahead, fill out the rest of this table, find the constant of proportionality, and then write an equation for the relationship. Go ahead and pause here. Come back once you're ready. All right, let's go ahead and move on. So from our length in centimeters to our length in meters, we can divide by 100, but our constant of proportionality always multiplies. So dividing by 100 is the same as multiplying by 1/100th. So 250 will end up 2.5. 78.2 will end up 0.782. And 123.9 is 1.239. So what we're doing is we're taking our length in centimeter y and multiplying it by 1/100th. So 1/100th y. So our constant of proportionality is 1/100th because we are taking our length in centimeters and multiplying it by 1/100th to get our length in meters. An equation for this is going to be our length in meters x is equal to 1/100th times our length in centimeters, which is y. Okay, let's move on to our very last problem of this task. And it is asking what is the relationship between the constant of proportionalities for these tables. So for the first table, the constant of proportionality is 100. The second table, it was 1/100th. What do these two numbers have in common? Go ahead and pause the video here, complete this problem, and come back once you're ready. So 100 and 1/100th. Both of these numbers are reciprocals. So 100 really has an imaginary 1 over it. So if we were to swap the place of the numerator and denominator, it would create 1 over 100. All right, let's move on to our next problem. And we're looking at filling a water cooler. It took Priya 5 minutes to fill a cooler with 8 gallons of water from a faucet that was flowing at a steady rate, so that rate did not change. We're going to have W be the number of gallons of water in the cooler after T minutes. So T is going to represent our time in minutes. Which of the following equations represents the relationship between W and T? There are 2 that are correct. And then what does 1.6 tell you about this situation? And what does 0.625 tell you about the situation? to help you with this problem, it might help you to create a table. So we're talking about gallons and minutes. We know that 8 gallons of water fills in 5 minutes. So go ahead, use this table, create your own table to help you solve these 3 problems. Pause the video here and come back once you're ready. Okay, so they got 1.6 and 0.625 from the constants of proportionality. The constant of proportionality will always be the number in your equations. So we just need to figure out which constant is coming from which side of the table. So I'm going to bring my gallons down to 1. And to do that, I'm going to divide both sides of my table by 8. 5 divided by 8 is 0.625. I'm now going to bring my minutes down to 1. To do that, I'm going to do 5 divided by 5, and then I'm going to take 8 and divide it by 5. 8 divided by 5 is 1.6. So, if our gallons is W and our minutes is T, from W to T, we took W and multiplied it by 0.625 to get the minutes. From T to W, we took T, our minutes, and multiplied it by 1.6 to get W. So we can find that in the equations A and D. W, gallons, is equal to 1.6 times T, and our T, time, is equal to 0.625 times W. So 1.6 tells us in this situation that in 1 minute, 1.6 gallons are filled. So we fill 1.6 gallons per minute. And then 0.625 tells us that in 0.625 of a minute, 1 gallon is filled. So 0.625 minutes per gallon. Okay, let's go ahead and move on to our next problems. Okay, so we're still looking at that filling a water cooler, and now Priya changed the rate at which the water flowed through the faucet. So we're writing an equation that represents the relationship of W and T when it takes 3 minutes to fill the cooler with 1 gallon of water. Go ahead and try and create another table. We are still talking about gallons. And we're still talking about minutes. But now we know that in 3 minutes, 1 gallon is filled. Hope that use this table, create your own table to help you answer question 4. And question 5 is, was the cooler filling faster before or after Priya changed the rate of water? So before she changed it to filling at 1 gallon every 3 minutes. Okay, go ahead, pause the video here, try the problems, and come back once you're ready. Okay, so I'm going to look at my table from W to T. We took our gallons and multiplied it by 3 to get our minutes. 1 times 3 gives us 3. So one equation we can write is T is equal to 3 times W. W is gallons times 3 would give us our time in minutes. Another way we can look at it is if we take our minutes down to 1. To do that, we would need to divide by 3 on both sides. 1 divided by 3 is 0.3 repeating, or 1/3. So from minutes to gallons, we take our minutes T and multiply it by 1/3. This is equal to our gallons W. You could have either of these equations, and they are both correct to represent this relationship. Now, we can also use this table to help us answer question 5. We want to know if the cooler was filling faster before or after Priya changed the rate of water. Well, before she changed the rate of water, we were filling at, it was 8 gallons of water in 5 minutes. Now, if we want to fill at 8 gallons, we're going to use our constant of proportionality, which is 3. And that is going to take us 24 minutes now. So that is going to take a lot longer than the 5 minutes it was originally for the same amount of water. So this means that the cooler was filling faster before the change. Because after the change, it will take 24 minutes to fill 8 gallons, whereas before it only took 5 minutes. All right, once you're done with this, let's move on to our last task. All right, now we're talking about feeding shrimp. So at an aquarium, a shrimp is fed 1/5 of a gram of food for each feeding. It is fed 3 times a day. So 3 times a day, it's fed 1/5 of a gram of food. You're going to complete the table and answer the next 3 questions. Our first question is, how much food does a shrimp get fed in 1 day? Question 3 is, what is the constant of proportionality and what does it mean in the situation? And question 4 is, if we switch the columns in the table, what would be the new constant of proportionality? Go ahead and try this problem, pause the video, and come back once you're ready. So in 1 day, they are fed 1/5 of a gram 3 times. So 1/5 times 3 is the same as 1/5 times 3 over that imaginary 1. And to multiply fractions, you just multiply straight across. So 1 times 3 is 3, and 5 times 1 is 5. So they are fed 3/5 of a gram of food in a day. So now, from 1 to 7, we would multiply by 7, and so we're going to multiply our 3/5 by 7 as well. And this is going to be 21 over 5. For 30 days, we're going to take 30, or 1 times 30, and 3/5 times 30, and that is going to be 90 over 5, which is the same as 18. So, our constant of proportionality, from our number of days to our food in grams, we multiplied by 3/5. 1 times 3/5 gives us 3/5. So, our 3/5 means that that the shrimp, one shrimp, gets 3/5 grams of food per day. So if we switched the columns in the table, the new constant of proportionality, so from food backwards to days, that is going to be the reciprocal of 3/5. We're going to flip 3/5. that is going to be 5/3. All right, let's go ahead and move on to the very last slide of this lesson. Okay, so we are going to use D for the number of days and F for the number of food. You are going to write two equations that represent the relationship. And then if a tank has 10 shrimp in it, how much food is added to the tank each day? And then if the aquarium manager has 300 grams of shrimp food for this tank of 10 shrimp, how many days will it last? So go ahead, pause the video here, try these problems, and come back once you're ready. So, two equations. We know from the number of days to our food in grams, we multiplied by 3/5. Going backwards, we multiplied by 5/3. So, one equation, our food in grams, F is equal to 3/5 times D. Our second equation is D is equal to 5/3 times F. Now, if a tank has 10 shrimp in it, we are going to take our 3/5 and multiply it by 10, because our 3/5 is how much food is fed to one shrimp. So we're trying to figure out 10 shrimp. So this is the same as 3/5 times 10 over 1. And then we'll get 30 over 5. And 30 over 5 is just 6. So they are going to feed 6 grams of food each day for 10 shrimp. Now, if every day they feed this shrimp tank 6 grams of food, and they have 300 grams, to figure out how many days it will last, we are going to take 300 and divide it by 6. This gives us 50. So it will last 50 days, which is almost 2 months. All right. We are finished. Go ahead. And now you're going to paste your lesson synthesis into the back of your notebook. Our lesson synthesis is saying, if Karan rode his bike at a constant speed of 10 miles per hour, his distance in miles D is proportional to the number of hours T that he rode. We can write the equation D equals 10T. So his distance is equal to 10 times the number of hours that he's riding. With this equation, it is easy to find the distance Karan rode when we know how long it took, because we can just multiply the time by 10. We can also rewrite the equation D equals 10T as 1/10 times D equals T, or T equals 1/10 times D. This version of the equation tells us that the amount of time he rode is proportional to the distance he traveled, and the constant of proportionality is 1/10. That form is easier to use when we know his distance and want to find how long it took, because we can just multiply the distance by 1/10. When two quantities are in a proportional relationship, we can write the equation y equals kx and say y is proportional to x. In this case, the number k is the corresponding constant of proportionality. We can also write the equation x equals 1 over k, y, and say x is proportional to y. In this case, the number 1 over k is the corresponding constant of proportionality. Each one can be useful depending on the information we have and the quantity we are trying to figure out. So I have underlined the most important information for you. And what this is basically saying is in the equation y equals kx, k is our constant of proportionality. And we know that the constant of proportionality between our table is going to be the reciprocal. So the reciprocal of k is 1 over k. And then we just simply flip the order our variables come in. And we have our second equation. All right. So once you get this pasted in your notebook, go ahead and move on to the cool down for today, and then don't forget to do both homework 2.4 and 2.5 before Monday. I hope you all have a very safe weekend, and I can't wait to see you on Tuesday. Bye.